Okay, this question is part one of some questions that are about mutually exclusive events. So we have three parts to this question, 1, 2, and 3. Each one uses or asks about something different, but they are all related to the idea of mutual exclusiveness. So what do we mean by mutually exclusive events? So if you have event A and event B like this, that they don't have an intersection, no intersection, so no part in common, then you say that A and B are mutually exclusive. And some people, instead of saying mutually exclusive, let me choose a different color, instead of mutually exclusive, they call them disjoint events. Disjoint. And there is a rule about mutually exclusive events. So we have, I will write the two rules here. If A and B are mutually exclusive, then the probability of A or B is the same as the probability of A plus the probability of B. So let's use a different color again so that you understand. Mutual exclusiveness or mutually exclusive implies that the probability of the or probability or the probability of the union is the sum of the probabilities without having to subtract anything. But if A and B are not mutually exclusive, then the probability of A or B will not be the same as the probability of A plus probability of B. So let us highlight this in another color. If they are not mutually exclusive, then the probability of A or B is not going to be the sum. It actually has a different formula. It will be probability of A plus probability of B, but minus probability of A and B. Let us solve the questions now by one. The first question is, it gives you the probability of A, 0.31, probability of B, 0.55, and probability of A or B is 0.86. And then the question is, are A and B mutually exclusive events? So how do we solve it? Mutually exclusive, if they are mutually exclusive, then you remember here, this one, mutually exclusive, then the probability of A or B must be the sum of probability of A and the probability of B. So let's see, what is the probability of A or B? It's given to us already here. So I'm going to write it. It's 0.86. And let us compare it to the probability of A plus the probability of B. And both are given again. Probability of A is given here, and the probability of B is given also. So just so you don't get confused, I'm going to erase the arrows. Probability of A is 0.31 plus probability of B is 0.55. If you add these up, you'll get 0.86. And notice that these two numbers turn out to be equal. So yes, this means they are mutually exclusive. So you can say, since the probability of A or B turned out to be the same as the probability of A plus the probability of B, we can conclude that A and B are indeed mutually exclusive events. Mutually exclusive events. So in this case, the answer to the question, if you go back, the answer is yes. They are mutually exclusive events, because it turned out that the rule for being mutually exclusive is met. Let's go to the second question. The second question here is asking you, if you know from the beginning that they are mutually exclusive events, if you know that A and B are mutually exclusive already, so immediately let's write what we know this means. This means that the probability of A or B equals the probability of A plus the probability of B. Okay, so let's keep this in a box and keep this in a box of the same color. Now, what also are we given? We are given the probability of A 0.21, probability of A or B is 0.64, and we need to find the probability of B. So if you look at this rule, since we already know that they're mutually exclusive, you can conclude from this rule that if you want to find the probability of B, then you can just take this probability of A to the other side, and so it will become with a negative. So probability of B will be probability of A or B minus probability of A. And so this will be probability of A or B is given here, 0.64 minus probability of A is 0.21, and this will give you 0.43. And let me put this in red, and this is the probability of B. Okay, so remember that because they were mutually exclusive, we immediately knew that we can use this rule, and from this rule we can get the probability of B, because we already are given the other two components of this equation. The equation here has three components, has probability of A or B, probability of A, probability of B. So if you know two of them, then you can find the third one. That's very simple. And so we get the probability of B is 0.43 using probability of A or B and probability of A, and the fact that they are mutually exclusive. Okay, so let's go to the next question. By the way, you don't need to do all of this, just, you know, just mutual exclusiveness gives you this, and immediately compute the probability of B. All of what I said is just to make you understand it better. Anyways, let's go to the next question. The next question is very interesting. It's telling you that if from the beginning you know that A and B are not mutually exclusive events. So here they are telling you not mutually exclusive. And before we continue, let us remember, not mutually exclusive, what does it mean? It means that the probability of A or B is not the same as the probability of A plus the probability of B, like this. This cannot be the rule. If you want to know the right rule to use, if they are not mutually exclusive, then probability of A or B will be equal to probability of A plus probability of B minus the probability of A and B. This is the real general rule for the OR probability. Okay? But in our case, they said from the beginning not. You see, not mutually exclusive. So immediately they're telling us that these two numbers cannot be the same. So let's see now what they also gave us. They gave us that the probability of A is 0.16 and the probability of B is 0.28. So the question is, which of the following values cannot be probability of A or B? And you have 4 answers. So now let's see probability of A or B. We know that it cannot be. It cannot be because they are not mutually exclusive. It cannot be the sum of the probabilities of A and B. But if you sum the probability of A plus the probability of B, you'll get 0.16 plus 0.28. And if you add these up, you'll get 0.44. So this is the number that it cannot be. Let's choose a different color. This is the number that cannot be the probability of, how would I do it? Okay, this cannot be probability of A or B. Otherwise, they would be mutually exclusive. So because we are given at the beginning they are not mutually exclusive, then this rule here cannot be true. So the answer to this question is you have to choose part C. This is the value that it cannot be. Probability of A or B cannot be this value, otherwise they would be mutually exclusive. Okay, and this would end this question.